So very good morning, students. This is Dhanlakshmi, Assistant Professor from Department of Computer Science Engineering, from Kongnadu College of Engineering and Technology. Now we are going to see about the fourth unit of Bit Analytics, that is MapReduce Programming and Hive. So MapReduce and Hive both are the high-level language which is used to process the semi-structured as well as your unstructured data. So this is what our introduction about the MapReduce. MapReduce and HDFS, which is nothing but Hadoop distributed file system, are the two major components of Hadoop to make the to store and access the unstructured and semi-structured data which is stored in your large data set to efficient to use. It is a programming model used for the distributed system in the way of parallel processing in a distributed manner, because in the wireless communication environment or a digital world, every data will be distributed in a network which is connected from your peer-to-peer network, and each and every data will be split up in a different separate systems, and it is important to access the data which is available in the distributed environment in a very efficient as well as a powerful way. First, the data is split up and it can be combined to produce the final result. The libraries for the MapReduce is written in different languages, because the MapReduce program can be supported in different programming platforms with the various and different optimizations power. So the purpose of MapReduce is to map each of the job, and then it will be reduced to the equivalent task for providing the less overhead during the cluster environment. Because if you are going to design an machine learning or a transfer learning, each you have to have different layers in between the input as well as the output layer. So it is not necessary to produce output for each and every input. It might be combined to produce a single input. For that purpose, we can able to use your MapReduce. So the two different phases of MapReduce is map as well as the reduce. So this is what the entire architecture of MapReduce architecture structure. First, the client will first give the job to the MapReduce. The Hadoop MapReduce master, the really master slave relationship between this architecture. The Hadoop MapReduce master will split up the jobs into number of ways. So first, the job parts will be reduced, and based on the input data and the job parts, the mapper will map the data, and it will be reduced in the another part and will produce the output. So these are all the components of MapReduce architecture. First, the client, job, Hadoop MapReduce master, job pods, input data as well as output data. The input data and output data is nothing but the user or client will give the data to the MapReduce architecture to reduce it. The output, it is the combined output which is produced based on the input after the processing. So the top four is the processing layer. The first is the client, which is the user who have to bring the job to the MapReduce for the processing. And the job is the actual work that the user or the client wants to do in a very precise and efficient manner. So which might be comprised of a small task, or it is a separate large task. So Hadoop MapReduce master, it divides a particular job into subsequent job pods based on the input data and the client job. It will be map the input data as well as the client job to produce the combined output. So job pods, just nothing but it is the job pods is available in n number of layers based on that input as well as the client job. It might be divided the main job into subtask, and the result of all the combined jobs will be produced as the final output in a reduced format. The reduced format will be done by the reducer. So here is the two different phases of MapReduce. The first, map, as I said earlier, it is to map the input data in a key value pair. We already discussed about the key value pairs based on the third unit. It is a document based type, so we are going to use a MongoDB here. The input to the map may be a key value pair, where key is the ID of the job part and the value is the actual value that it keeps in the particular key. So this is what your input, and based on that input and the job, the map phase will map the input as well as the job of the client, and it will produce the and it will send the output to the reducer phase. The reducer phase is the intermediate key value pair that works as an input for the reducer, and it gets shuffled and sorted to reduce by using the reducer function. Is the input function of the MapReduce algorithm. The reducer will aggregate or group the similar data based on the key value pair as per your reducer algorithm. So the next two are the other important components of MapReduce, that is what your job tracker as well as your task tracker. So job tracker, the work of the job tracker is to manage all the resources and all the jobs, whether the necessary resources for the job are allocated across the cluster, and it also schedule each map on the task to running on the same data node, whether it works on the proper way, and also it assign the necessary resources to the job. The entire thing will be tracked by the job tracker, which is available in the same data node. So task tracker, it's actually as act as a slave. So entire MapReduce architecture will work based on the master slave. So the job Hadoop master will assign the job, and the task tracker or act as a slave to perform each and every subtask, which is divided by the is divided as a main which is divided by the job part. The slaves that are working on the instruction given by the job tracker. So the task tracker is deployed each and every node which is available in the cluster that executes the MapReduce. So there is one another important component of architecture is job history server. It is a daemon process that saves and stores the historical information about the task or the applications. What are all the tasks which will be performed by the particular cluster environment or in a distributed environment, and it will maintains the list of process, and it saves in a database as a history. So it's like a logs which are generated during or after the job execution, just stored on one job history server. So combiner, it is also known as a semi-reducer. It is not actually a reducer. It is a semi-reducer. It's an optical class by accepting input from the map class after processing the output as a key value pair to the reducer. The main function is to summarize the map output records with the same key, which is just nothing but it combines the uh, similar data based on the key value pair. Before it sends to the reducer, it acts as a semi reducer which combines the similar data of the um, a similar data output which is get from your map phase, and which will send over to the network as an input to the actual reducer task. So it will be works between the map class and the reducer class to reduce the volume of data to be processed or to be reduced by the reducer. This is what a reducer architecture. Here the input was given, and the k1 is to v, k1 is to v, k2 is to v is nothing but your address, and this is a key value based on the key. The actual value will be stored in the particular address, and in the combiner phase the output from your map phase will be reduced or will be combined based on the group, and the combined values will be sent to the actual reducer, and it will produce the output. So here it is we have to discuss about how the combiner works. It is not a predefined interface. It will be by the client. So it is implemented by the reducer interface of a reducer method. The same reduce method will also be applicable to your reducer base phase, but it have a separate reducer algorithm. But in case of combiner, it does not have a reducer algorithm. It is a reducer function, it is an inbuilt function which is imported during the execution. Based on that jobs given by the client, it can be reprogrammable. So it operates on each map output key. So it combines the same output key values as a reducer. So it produces a summary information about the large data set, but it replaces the original map output. So partitioner, it works like a condition in an input. In a input database. Partition based on certain condition, it will partitions the data. So this is a base for your random forest algorithm, which is work in a machine learning. Here, that the random forest algorithm, which combines the condition based on certain condition, it will combine the like data. In that way it will also work. The partition will divide the data according to the number of reducers. So the number of reducer will be fixed based on the partition works. So the partitions will works on the intermediate map outputs. Before it entering into the reducer, it will partition the data after the combiner, which give the reduced input to the partitioner. The total number of partitions is same as the number of reducer tasks for the any other job L. So compression. So data compression is very important in the MapReduce architecture because we have to combine the data without any loss. So what is the major benefits of the combiner is compression is it reduces spaces needed to store the file, as well as it speed up the data transfer as well as the data processing across the network. So if the job output use sequence file type, they use the different combined method as record, block or none. Thank you.